Hello everyone. We will start the class. Will you be able to see this slide? You can, right? So let me correct this. This is Z, this is X. I hope you can see the slide. So I'll start the class now. This is the question from set 2 of the GATE 2022 Civil Engineering paper. So let's go through the question first. Stresses acting on infinitesimal soil element are shown in the figure, where sigma z greater than sigma x. So this is greater than this one, and the major and minor principal stresses are sigma z and sorry this is not sigma z and sigma x, let me correct, this is sigma 1 and sigma 3. Okay, the major and minor principal stresses are sigma 1 and sigma 3 respectively. Considering the compressive stresses as positive, which one of the following expressions correctly represents the angle between the major principal stress plane and the horizontal plane? Fine. So here what are asked? See here, if you see, this is greater than this is the given data. Sigma z is greater than sigma x, whereas tau zx is same all over the element. See, shear stress will always be same. The only thing is the coupled direction which will be formed by the shear stresses will be different direction. That's it. You see, this and this will make anti-clockwise, right? Anti-clockwise couple, whereas this and this one and this one will make clockwise. So that's how this is in equilibrium, right? Both are equal and both are making same amount of couple. And then coming to here, sigma z is more than sigma x. Because of that and because of the shear stresses, there will be many number of stresses will be developed in the different planes of this element. Now for knowing which one of the following expressions correctly represents, so there are 4 expressions which are given, right? So it is said that, it is asked that angle between the major principal stress plane and horizontal plane. See, this is the horizontal plane here, this one and this one, these two are horizontal planes within this element, right? And there is some another major principal stress plane, that means major principal plane, that's it. What is major principal plane? The plane on which sigma 1 is acting is called major principal plane, because this is major principal stress. So let us say this is the plane on which this sigma 1 is acting. Okay, so what do we have to find out? The angle between the horizontal plane and major principal plane. We have to find out that, and one of them will be equal to that. So anyway, so can you tell me, can one of you tell me, or anyone, what is the shear stress value on this plane? So this plane which is highlighted. Can someone reply? Anyone? You have been listening this. Yeah, tell me. S equal to C plus sigma tan pi. Okay, so I am asking what is the shear stress on this plane? On this plane. This plane. See, what are principal planes? What are sigma 1, sigma 2? They are principal stresses. But why are they called principal stresses? On that plane where they are acting, right? So what is the shear stress on this plane? 0. That's it. Anyway, so that is what I was asking. So let's go to the, see, you know the concept of Mohr circle, everyone. So if you can draw the Mohr circle, then by using the pole concept, I have taught you pole concept in the last class. Again I can repeat this today so that it will be refreshed again. So let's go and let's draw the Mohr circle for the given soil element. Can you mute yourself? Who is that? Yeah. What is the given element? Sorry. Sigma z is acting vertically down, vertical, in vertical direction. This is sigma x. So all are compressive loads. Okay, here compressive loads are positive, okay, as per the given question. And the given question, this is anti-clockwise. The shear stress which is, and if that is anti-clock, this should be clockwise. So this is tau zx, everything. So now what was the concept of drawing Mohr circle? To draw any circle we need 2 points, okay, and those 2 points should be the ends of diameter. So here what are those 2 points? Generally coming to the soil element or any element which is subject to the stresses, you have to take the 2 planes which are perpendicular to each other, okay. Then you have to take the stresses on those planes which are perpendicular to each other. You have to take those 2 stresses as 2 points. Then you have to draw those 2 points in this sigma tau phase, sigma tau plane, okay. This is sigma axis and this is tau axis, okay. Now let us write the points first, okay. I'll go and 1 minute. Let me copy this. Yeah, first of all let me write those points first. Point 1, sigma z comma tau zx, sigma z comma sigma z comma tau zx, right. And another point 2 is sigma x comma again tau zx. But here if you see, this is anti-clockwise shear stress, whereas this is clockwise shear stress. So that must be, they must be having different signs. Okay, suppose if it is positive, it can be negative, it will be negative. If it is negative, it will be positive. So you can take anything positive, anything negative. Let us, generally we go for anti-clockwise couple is positive shear stress. Okay, like that. So let's go for positive for the sigma z and tau zx. Okay, anyway sigma z and sigma x are, they are positive because they are compressive loads, and tau zx I am taking anti-clockwise, okay, as positive, and another one is negative. So I'll keep positive symbol here and I'll go for negative symbol here because it is making clockwise couple. Okay, so as you have 2 points and 2 points are the ends of diameter because they are on perpendicular planes, and you know sigma z is greater than sigma x. So let's go for drawing the Mohr circle, taking all those inputs. So let me draw. Okay. Right. So what are those 2 points? Sigma z comma tau zx is 1 point, another one is sigma x comma minus tau zx. Here if you see, this and this magnitude is same, whereas only the like sign is different. Suppose if it is, let us say 10 comma 5, it may be other than 10, let us say 7, it is again 5 but it is minus 5, that's it. It is just two numbers. Okay, so as this is tau and this is sigma, let's go for first this point, sigma z somewhere here on sigma axis and tau z somewhere here. Okay, give me a minute. So can you tell me, can you see the slide? Can you hear me? Yeah, fine. So let's take these 2 points first, sigma z somewhere here, let us say. Okay, now tau zx is the height somewhere here, let us say. Okay, this is tau zx magnitude, and bottom side also same, right? Tau zx. So this point is minus tau zx, this one is plus tau zx. Okay, now this is sigma z. Somewhere here we'll go for somewhere here. Let's see first. So what is this point, tau zx, and if I draw, it will come somewhere here. Okay, this is the point tau z comma, sorry, sigma z comma tau zx, and another point will be sigma x. Sigma z is greater than sigma x, so sigma x will be left side to the sigma z somewhere here. Okay, let's draw here at this point. Okay, so this is the point. sigma x comma minus tau zx. So after drawing these two, means after noting down these 2 points in this plane, so what is the another next step to draw the Mohr circle? You know the endpoints of diameter. What do you do now? Next, just join them. Okay. Okay, see now this is the diameter. Wherever it cuts the x axis, that should be the center, right? That should be the center, because if you see this height and this height, they are same because they are tau zx. Next is this angle are same. It is just that midpoint of 2 points, it is suppose x1 comma y1, x2 comma y2. What is the midpoint? x1 plus x2 by 2, y1 plus y2 by 2, right? Here what is x1? Sigma x plus sigma z, sigma x plus sigma z by 2, midpoint. Another one is what? Tau, sorry, let me write somewhere here. Okay, let me write, the midpoint will be sigma x plus sigma z by 2 comma tau z plus minus tau z x by 2. So this is 0. So that means the y coordinate is 0. So here also y coordinate is 0, only x coordinate is there. That is how this becomes center of the circle. Now you know the center of the circle and you know the diameter. Okay, you can complete the circle first. Okay, so how can we do that? Just take compass and you can finish it off. For the time being, let me draw. Okay, it may be bad circle. Okay, now this is the circle, Mohr circle. Okay, now I have drawn Mohr circle. 2 points are there. The given data is over now. You have drawn by taking the given element. Element was given sigma z and sigma x, and then there is some shear stress here. Okay, tau zx and tau zx. Sorry, tau zx. But what else we have to find out now? Principal stresses. Principal stresses are also given. What are they? Sigma 1 and sigma 3. Sigma 1 is major and sigma 1 is minor principal stress. So here in this circle, wherever it is touching this x axis, okay, these 2 points on the Mohr circle, y coordinate is 0. That means shear stress is 0. Here also shear stress is 0. That means the stresses should be principal stresses. So it must be sigma 1, it must be sigma 3, right? That's how we can find out what are the major and minor principal stresses on this Mohr circle. What is the next point? What we have to do? we have to find out the angle between major principal plane and horizontal plane. Okay, now for that pole is, let me erase this first. Okay, what is the concept of pole? What are the instructions? You have to draw the lines in the same angle. Suppose you just see the, if you see given element, this is sigma z and this is sigma x, right? So now taking this sigma z, on which plane it is acting? Sigma z is acting on horizontal plane, right? So I will draw one horizontal line through this point. Okay, so I am drawing a horizontal line through this point. So this is the horizontal line. And what is the another stress? Sigma x. So this sigma x is acting on vertical plane. You just have to draw vertical line through this sigma x. Okay, let's draw that. Okay, let me erase this first. Actually circle does not look like this, it looks it should pass through this. Okay, let me again. So this is sigma 3. So now this, if you draw these two lines on which these stresses are acting, and these stresses are acting on perpendicular planes, two perpendicular planes. Whenever you draw those two lines, those two lines will meet definitely on the circle. Okay, so this, the intersection point of those two lines which you have drawn just now, this is horizontal line because it is acting on horizontal plane, and this is vertical line because it is acting on vertical plane. The intersection of them is now pole. So now pole concept is used to know the angles of any plane. You can randomly, suppose this is this is sigma 1, right? So this is sigma 1. If you connect pole and sigma 1 with respect to this element, given element, so this is the angle between the horizontal plane and major principal plane. So what is this line? This line connects pole and major principal stress. That means this is the major plane. That is the concept of pole. So from the pole you can draw many number of lines like this. Suppose this is the this is a line, and this, wherever it is cutting the circle, suppose there are some stresses, right? There is some sigma here, let us say sigma I comma tau I. So this point represents. Now this plane in this element, so let us say after finding you found out, let us say this is 26 degrees. Okay, so you can draw a line here 26 degrees line. So this is the plane in this element which is subjected to this much normal stress and this much shear stress, sigma I and tau I. So that is the concept of pole. From the pole, wherever you draw, just reproduce same lines with the same angles in this element, you will get the angle of plane. You can represent the plane in this element. So anyway, so coming to let me complete this circle first. So coming to, then what is this called? This is major principal plane, okay, because the pole and sigma 1 is connected together. And this is the, suppose now you can say from in reverse engineering, from the pole you have drawn a horizontal line now and it is connecting sigma z and tau zx, because previously only we have drawn a horizontal line from here. Now what I do, I will draw from here another horizontal line. Those two should be coincided each other, because wherever it is touching the circle, where is it touching? It is touching here. So you just see, so on the horizontal line with 0 degrees, okay, on horizontal plane, these are the stresses, right? These are the stresses, just like that. Now if you can find out what is this angle, then you can compare with the options which are given here. So how to find out this angle? Let us draw this clearly. Okay. Okay. First let me draw. Alright. So this is the more circle, and somewhere here and somewhere here sigma x comma minus tau zx and sigma z comma tau zx. Okay. Now this is sigma 1, this is sigma 3 comma 0, sigma 1 comma 0. So now the pole is here, pole is drawn, right? So this is the pole. So now what do? We will join, sorry, this is sigma 1, let me correct, this is sigma 3. So we are joining these 2 points so that I will get 2 planes. One is horizontal plane and another one is major principal plane. So to find out this angle, I can extend this. I'll just extend this. Okay, I'm just connecting these two so that I can form a triangle. Let us say this one is M and this one is P and this one is O, this point. So there is a triangle MPO, right? Now let us say this is alpha, which we have to find out right now. Okay, now can you tell me what is tan alpha from this figure in terms of sides, like MPO? One side is MP, another one is PO, and another one is OM. Okay, and this is a triangle which I have drawn from here to here so that it forms 90 degrees. A vertical line from here and this horizontal line up from here, it is extended so that it is formed. So this is 90 degrees. Okay, now this is alpha. Can someone of you tell what is tan alpha in terms of these sides? OM by OP. Can you tell me what is OM? What is the magnitude of the OM in terms of stress? Tau zx. Why? This height is tau zx, right? Okay, tau zx. Can you tell me what is OP or PO from here to here? Sigma 1 minus sigma x, right? Why? See, I want this OP from here to here. So if you see, this is sigma 1 vertically down and this one is sigma x. So if you deduct sigma x from sigma 1, you will get this. So I am just doing that here. So I am rewriting again, tan alpha equal to tau zx by sigma 1 minus sigma x. See, you may be confusing, you may be writing sigma z minus sigma x, but that is not. If you write sigma z minus sigma x, you will get this one only this much. But I need from here to here. Remember, from here to here. See, this is sigma 1. So most of you definitely can be confused. That is the reason why I am highlighting. It is not sigma 1 minus sigma 3. It is not sigma z minus sigma x. It is sigma 1 minus sigma x. Okay. So now what is alpha? Tan inverse tau zx by sigma 1 minus sigma x. Okay. So let's see whether, see what is the angle. Now this angle is in between horizontal line and major principal plane, right? So that is the question. Horizontal plane and major principal stress plane. What is the angle between them? Tan inverse of tau zx by sigma 1 minus sigma x. Can you tell me what is the option? Can any one of you tell me which option is correct? A. So this is the answer. Tan inverse of tau zx minus sigma 1 minus sigma x. So I hope everybody understood. If you have any doubts, you can ask me. Does anyone have doubt? If you cursor point shows on the screen. Yeah. Okay, Manabendra, I will do that. Actually there is some small issue in this. I'll do from the next class that. Yeah, that's why I'm highlighting. Whenever I'm showing some plane, I'm drawing on that plane. Okay, I'll do that in the next class. Is there any doubt? So can I move to next question? Yeah, okay then. So let us move to next question. This is the question number 40 from the set 2. Match the following in column X and column Y. Okay. Let's read all the column X first. Okay. In a triaxial compression test with increase of axial strain in loose sand under drained shear condition, the volumetric strain, what does it, so what does this how does this volumetric strain change? when axial strain increases. So when the loose sand is tested in the triaxial compression test apparatus. Okay. Now another one is same triaxial test with the increase of axial strain only, again loose sand under undrained condition. Here drained condition, here undrained condition. The excess pore water pressure. Okay. Here volumetric strain. What does it means? How does they change? How do they change? That is what it is asked. And another one is in a triaxial compression test, again the pore pressure parameter B for a saturated soil is what? And another one is for shallow strip footing in pure saturated clay, Terjaghi's bearing capacity factor NQ due to surcharge. So here they are asking the value of this. So can anyone tell before I start? Okay, let me start then. So what is the first one? Left side of the left column, it is axial strain versus volumetric strain, right? So in drain test, what you have to understand first, see, generally axial strain will be drawn on x-axis and volumetric strain will be drawn on y-axis. This is, see, if the volume is increasing, that is called positive. So don't think that when suppose this is compression is positive, then if compression is there on the soil element, it may be the volume may be reduced. If the volume is reducing, delta V will not be positive just because this is positive. Delta V is negative because it is decreasing. You just have to think in that way. Okay. So whenever the volume is decreasing, the amount which how much it is decreased, that is delta V, and that is negative if it is decreasing. Anyway, so let's go back to the question again. So what is the relation in the drain test when the axial strain is increasing? When the axial strain is increasing, so what happens to volumetric strain? There are what is it asked? The triaxial compression test, the increase of axial in the loose sand. Okay, this is what the hint. So there are two types of sands. Actually there are many types of sands, but here majorly we will divide into two things. One is loose sand, another one is dense sand. Okay. Now loose sand has lot of voids when compared to dense sand. So when there are voids, okay, when you are compressing this sample, the loose sand, what will happen? The voids will reduce. That means this total volume will decrease because it has option. It has the capability of decreasing. Whereas taking the dense sand, already it is so much compacted. The soil particles are very near to each other. Okay, whenever you are applying some load on this, it will try to roll over each other, all the particles. When they are rolling over each other, what happens? Voids will increase, the total volume will increase. That's how dense sand and loose sand behave when the load is there. So how can we draw now? So for the loose sand, volume will decrease. So you can, loose sand may behave like this. Whereas dense sand, initially the moment when you apply for some time, the volume tries to decrease, but after that again when they readjust and when they roll on each other, then the volume will increase. For small time or for small axial strain, it might decrease, but later it will again increase. So this is how, this one is loose sand and this one is dense sand. So here volume is increasing for dense sand, here it is decreasing. Now let's see any option. So what is it say? For loose sand, the volumetric strain increases or decreases? So decreases. Let's go for this option. Okay, P1. And second one is intra-axial compression interest with increase of axial strain in loose sand under undrained shear condition, the excess pore water pressure will be. Okay, see, whenever the voids are, the volume of voids decreasing, what happens? The water which is inside will go out of the voids. That's how the volume will decrease. That's how the pore pressure will increase. Okay, whenever you are applying some load, first the water will be taking, because the voids are filled with water, then water will be taking. Then pore pressure will increase. Pore pressure will increase only in the loose sand, where if you take the dense sand, when you are applying load, due to the increment in the voids after the application of the load, because when you apply the load, dense sand has only tendency to increase the volume. So then when the volume is increased, it will suck the water, because there will be a suction, vacuum created in the voids. Because of that, water will be sucked inside. So that is negative pore water pressure. Okay, only pore water pressure will increase in loose sand. So let's see the question. Then again loose sand, excess pore water pressure will increase. Okay, so whenever negative pore water pressure is happening, that means you can say that it is decreasing. Okay, it happens in over consolidated clays or dense sands. So now again next is Q2. In a triaxial compression test, the pore pressure parameter B for a saturated soil. Can anyone tell that? What is the value of that B? Okay, see, you should know there are two pore water pressure parameters. So let me, pore pressure parameter, there are two parameters, one is A and another one is B. See, you can go through that Gopal Ranjan textbook, there will be derivations for these two. So I can give you the direct formula for this, for B, that is 1 by 1 plus porosity into coefficient of compressibility of pores and coefficient of compressibility of soil skeleton. This is the formula for B. See, when the pores are filled by water, water is incompressible material. When it is incompressible material, fully saturated condition means what? Fully saturated condition means pores are filled by water, total pores. So when the water is incompressible, this value is 0. When it is 0, B equal to 1. So that's how the value of B is always 1. So you can say R is 5. And another one is, this is you just have to remember this, whenever you are taking the pure saturated clay, the bearing capacity factor NQ is this is 1, whereas NC is 5.14 and N gamma, these three are, this is 0, these three are bearing capacity factors for pure saturated clay. So what is this? Again 1, again 1. So S is again 5. So option is A, P1, Q2, R5 and S5. Okay. So any doubt in it? If you don't have doubts, I will close the session for today. So let's see a new gate paper next time onwards. Like next week, I'll go with gate 2011, yeah, 2012, yeah, around like that. So don't share your entire screen or anyway. So can I end the meeting? Yeah. Thank you everyone. Let's meet in the next class. Yeah.